All right, guys. So we are on our final day, and then you're on summer vacation. So nothing says fun in science class more than fire. So today's experiment, I have to say over and over, please do not do this at home by yourself on the sidewalk or anytime. Just don't try this by yourself because there is fire involved. This is a video that is for observation purposes only. Okay? So if you continue to watch this, you are taking an oath that this is for observation purposes only. Are you ready to do this?
Yeah.
Okay. So we are going to make a serpent snake. What we have in here is sand. What we are going to use is powdered sugar, baking soda, fire, and some lighter fluid. How we're going to measure this is with measuring spoons. Specifically, a tablespoon. So, in our sand, we are going to put a hole in the middle, just so it can kind of give us a little circle, so we can pour our things into. Now, we're going to take a bowl, and we are going to mix our baking soda and our powdered sugar. What we're going to do is it has to be 1 part baking soda to 4 parts sugar. What that means is there has to be 4 times the amount of sugar that there is to baking soda, okay? So you just have to multiply however many spoonfuls of baking soda I put in, I multiply that by 4, and that's how much I put in of my powdered sugar. Yes, science and math are always crossing paths. Get ready for next year. So, I'm just going to use 1 tablespoon. 1 tablespoon of baking soda. Put it in my little dish. And then I'm going to take, because I did 1 spoon, I multiply that by 4. 4 times 1 is 4. Take this. 1, 2.
No others.
3.
I saw an egg.
Oops. And 4. So there's 4. Now we're just going to mix it around.
Hey.
Make sure that's stirred up all nice and good.
Can you stir it?
Yes, you can, son. While he stirs that, I am going to get the sand ready. You want to use your finger?
Yeah.
All right, go ahead and use your finger. What I'm going to do is I'm going to soak the sand in the area that I want to put this in with a lighter fluid. Are you mixing it or are you playing with it?
I mix it.
Okay. So now I get my lighter fluid, put it right around the spot that I want it to light on fire. Okay. Maybe a little more. Okay. Now again, we do not play with lighter fluid. We do not play with fire. This is for a science experiment, observation only. Okay. You stir it nice and good? Yeah?
Yeah.
All right. So now we're going to pour this in the middle. And now I'm going to attempt to light it on fire. There has been a slight breeze out here all day, so I'm hoping it still works. Ready? Back up a little.
Yeah.
Have a seat. Thank you. And the breeze made it go out. Shall we try again?
Can I try?
No, sir. You are too little to play with fire. Oops, pressed that too hard. The breeze is killing me, guys. The breeze is killing me. And there we go. I got it started. And now we shall see what happens. Alright guys, so what you see here, and I'm going to turn this because I think this looks cooler on this side. What you see is a chemical reaction. Some of you learned about this already, and if not, I think we will go into depth about it. We'll go into further depth about this in the 8th grade. Maybe, I think. We'll have to see how COVID treats us. And so what this is the sugar is what's actually burning here. It combines with the baking soda, but the sugar, as it burns, has oxygen in it. So that oxygen releases carbon dioxide, which is a gas, and water vapor, which is the gas form of water. As it burns, it usually just turns into gases and floats into the air when we have normal fires. Now, because around it forms with the baking soda, and with that, it doesn't allow it to completely grow out. Because the outside starts to burn first, it encases the sugar. And when it encases it, the inside sugar has a lack of oxygen. So because it can no longer turn into CO2, a gas form, it starts to get hard and it carbonizes, creating this dark black stuff. And then it begins to grow because all that sugar is still burning, but it has nowhere to go. So then it begins to grow. Now, baking soda releases other kinds of gases and also gets captured in there, which is why it helps it stay encased. The two together combine, causing the chemical reaction. Now, the sand does not create a chemical reaction. The reason why we use sand is because sand takes a long time to get hot. And because it's a bunch of little tiny rocks, instead of one giant rock getting hot, because there's a bunch of little ones, the heat from the fire disperses all around, causing an even area to get hot, causing the serpent to get hot all around and staying warm for it to continue to get hot. If we use something else that got hot faster, then this would not grow as big because the fire would go out sooner. So that's the whole point of the sand. Also, to not burn stuff. That's also very important. So there you have it. Now I have one that we did previously that I want to show you. My son kind of destroyed it, but when we do this still has little tiny flames going around in it. So it's not growing as fast anymore. But once it stops, I want to show you guys. This looks like it would be rock hard, but actually it's kind of fluffy. And it kind of feels like what you think a cloud would feel like. But I want to show you, as you can see when you rip it apart, it has a bunch of holes in it.
Feels like moon sand.
And when you pick it up,
Kinetic sand.
you can see the unburnt sugar and soda. that it wasn't able to get to because it couldn't burn because there wasn't enough oxygen. It got stuck in there. So, again, I repeat to you, this is not something you try at home by yourself. It's not something you go to a friend's house and try. You do not try this because it has to do with fire and stuff that combust, okay? And this is for observations. Now, if we're in the classroom next year, maybe we'll get a chance to try this together. I hope you guys have a great rest of the year. In your comments, you are to tell me what you learned and what you thought was cool. And tell me what you are excited about for next year. Have fun, guys. I'll see you next year. Adios!